Hello grade 12, welcome to my channel. Let us have a look at this question 3 from November 2024 as part of the finals. Okay, so this is still a question on VPM. So this is you and I just trying to get that consolidation done. Of course guys, please make a habit of practicing as many different questions as you can, applying the same ideas being shared here. You will not regret it, because on top of just knowing how to do these things, you will start to understand how these things work, which is the most important. We are told ball A is thrown vertically upwards at a velocity of 12 meters per second. So if this ball is thrown, it means it has some initial velocity, and in fact this is already stated, so we can easily jump for the jugular. It is a projectile. All right, so that's what we understand. Okay, from the top of a building. Now guys, it helps to visualize again the story. Let's say that's the building. Okay, so there is our building. Nice. So we've got our ball A, and it is thrown upward. So we know that as it goes up, it reaches maximum height, it will then come down. The trajectory here is very important, and there is our ball on the ground. Okay, so this is what we can understand. And then of course we are told that its initial velocity is 12 meters per second upwards. This is very important. All right, so what do we understand? At maximum height, the velocity is 0. It's always the case. That's another very important piece to keep in mind. Okay, drawing the trajectory is very important guys, because without it sometimes it gets a bit hectic. So try to visualize what's going on. Now we're told also that 2 seconds later, ball A was thrown upwards. Now a ball B is thrown vertically downwards. Okay, vertically downwards at this velocity of 5.4 meters per second from the top of the same building. So this means 2 seconds later, here's ball B is essentially thrown straight down, and there it is on the ground some time later. Okay, so not a big deal. So it's going like this, while this one has gone up like that. Not a problem. So we have an understanding, we've got a sketch. This can help us to then move forward. We are told both balls strike the ground at the same time. And what is this time? T seconds. Okay, both balls A and B strike the ground at time T seconds. That means the same time. Then here comes our famous statement: we are to ignore the effects of air friction, and this means G is basically 9.8 meters per second squared down. So that statement gives us that value. We need to know that. Okay, so we're told here the position time graphs of both balls are shown below. Okay, we can see that this is for ball A. The trajectory is exactly as we have shown it here. And then we've got that for ball B, which is straight down. Again, we know that the mathematical functional model is that which fits a parabola, a grumpy face parabola. So it's parabolic when we look at that position as a function of time. Okay, it's only because of that issue of time that makes it look like that on the Cartesian plane. Not a problem. So we are told using equations of motion only, nothing else, guys. No energy principles. So this is a strict rule. We need to calculate the value of each. So if we're just doing the value, we're just focusing on magnitude. So there's many ways of saying the same thing. So the examiners become very creative. Sometimes they become very subtle, very vague, so that you start dying a slow death. Okay, as shown in the graphs. Okay, not a problem. We want time t. So this is the time when they reach the ground. So that's not a problem. It's a 5-mark question. So this means it's one of those silly questions. It's the suplexities of VPM. Okay, let's get to question 3 nicely. Now we have 3.1. Now we need to choose a direction. So we're taking upward as positive, guys. Okay, please, this choice must be very clear. So this means for every question in 3.1, this is the choice, because it's always nicer to be consistent. To drift around is dangerous for you, not for the examiner and not for the marker, but for you as the student. You may be misunderstood by your marker and you end up losing very fat and tasty marks there. Alright, so what this time t? So guys, we know only the initial velocities for this one. So the initial velocity was 5 meters per second down, and the other one was 12 upward. So we only know the initial velocities and that they reached the ground at the same time. Now the question is, guys, if we think about it, what displacement did these balls experience? Now if you see this, we will notice that actually the displacement is this height of the building, because both of these balls have been displaced exactly downwards. Wanted to highlight it with that thing, but it didn't do it. So these two balls are starting there and they're displaced downwards. So this is the same displacement, delta y. Even though ball A went all the way up, of course that's an upward displacement which we could calculate at some point, right? But the nice thing is that it goes up and comes back down the same displacement in opposite directions. So that cancels out. But the displacement in totality in relation to where it started is exactly there, because displacement is the distance or the position from starting to the end. The rest of the other shenanigans don't matter with displacement. And the other one is just straight down, which was easy. So they each have been displaced the same way down. Okay, this is very important. And over the same time duration, although there was a time lag between the launch of the two balls. Not a big deal. So we're going to use that to our advantage. We know that the delta y for ball A is going to be the initial velocity times delta t plus half g delta t squared, because we know that we are covered when it comes to the initial velocity, and also we are covered because this delta y is the same thing, and it leaves us just one unknown, time. See, this is why this is good. Now let's continue simplifying. using our mathematical gymnastics. Aibo dabhalo a abayitungo. Delta YA is essentially, we chose up as positive, so this is 12 into T plus, let's make it 0.5 into minus 9.8 into T all squared. Therefore, delta Y for A is going to be 12T minus 4.9 T squared. We can make that equation 1. So this is what we can get for ball A. We can say also, we know that delta Y for ball B, since this is the same displacement, but we can use the similar equation. But now I'm not keen on writing that same equation. I'm just gonna go straight into okay, let's not rush. This is the same as the initial velocity times delta T plus half G delta T squared, okay? This implies that delta Y for ball B is, the initial velocity is 5 but downwards, so this is going to be minus 5.4 into T, but remember there was a 2-second lag, so meaning this T is going to be shorter by 2 seconds, so this is going to be minus 2. This is the key area plus, let's make it 0.5 into minus 9.8 into T minus 2 all squared. Sometimes I slant downwards, sometimes I slant upwards. I don't understand this thing. It really freaks me out. What motivates this slanting? I have no idea. Anyway, let's simplify this thing. So this implies that delta Y for ball B is, we distribute this is minus 5.4 T plus 5 by 2, that's 10, 0.4 by 2, that's 0.8, so this is 10.8 T, no, there's no T, and then this is going to be minus 4.9 into, we sort this out, it's going to be T squared minus 4T plus 4. All right, okay, all right, so this implies that delta Y, so there's a lot of simplification here, is essentially we distribute this in using all the knowledge of maths. So we know that this is going to be nothing but minus 4.9 T squared, okay? And then when we multiply this by 4, it's going to be a positive thing. So minus 4.9 into minus 4. It gives us 19.6. So this is going to be plus 19.6 minus 5. Okay guys, I'm moving quick now. This is 14.6. T. Okay, so again we're gonna get minus 19.6 from the other one, minus 19.6 plus 10.8, so we get minus 8.8. Of course you can go through the steps nicely, so we can make this one equation 2. So we've got these two equations, but what have we noticed is that this is the same displacement. It's nothing but the same delta Y, because they each got displaced downward the same way. So we can put them together. We can start with this one or the other, it doesn't really matter. Let's start with this one. So we've got 12t minus 4,9 t squared is equal to minus 4,9 t squared plus 14,6 t minus 8,8. Why? Because we know that equation 1 is equal to equation 2. It's the same displacement. See, the slanting down has started now. Damn it, man. Damn it, man. Alright, okay, alright. So we know these ones are the same sign on either side of the equation. So they will take each other out. So we need to bring this guy back there. So when we bring this back, we get minus 2,2t equals. Is it 2,2 or is it 2,6? What am I doing? 14, bing bang, it was 19,6. Ne? Yeah. Wait. Yeah. That was 19,6 minus 5,4. That was 14,2. Yay. Bad mistake right here. So it's a bad mistake. So be careful, guys. Sometimes when you do things too quickly, it can hurt. Okay, so let's see, minus 14,2 plus 12. Yeah, that's the one. So we have minus 8,8 here. Therefore t is going to be minus 8,8 divided by minus 2,2. So 8,8 divided by 2,2, it's 4 seconds. Okay, so that's the time t. Nice and easy, guys. So we can see that this was the suplex city. So it's one of those higher grade questions. So please get used to this simultaneous equation stuff, because that's exactly what we need to do here. But paying attention to what we have, because that's the thing. Alright, okay, alright. Now we saw that essentially that displacement is the same as this one. Right? Okay. So that's the one. Nice and easy, guys. So this is fine. We can get a mark for this equation right here. And then we can get a mark for that final equation. We used a similar equation, but the substitutions are special. And getting that equation is also special. So substituting the two into the other is not really a big deal. But what is a big deal is the answer. Of course, this could have been 7 marks. 6 marks at best when we equate the two. But yeah, so they chose to give us 5. Okay, let's move on to the next question. We have 3.1.2. We need to find z. So z is nothing but this height of the building. So we can use any one of the two equations above. So we know that z is going to be equal to delta y, since we showed it. Or perhaps let's not even waste time. So we can use the first one because it's much easier. 12t. Let's just first write it. 12t minus 4,9 t squared. This implies that z is 12 into 4 into 4,9 into 4 squared. That square is crazy. Therefore, Z is, let's see, this is 12 into 4 minus 4,9 into 4 squared. We get minus 30,4 meters. Right? Therefore, remember, all that was needed was just the magnitude. So we can write it as positive 30,4 meters. As much as we know it's a displacement, the negative sign only explains the fact that this ball was being displaced downwards, but now its displacement is exactly the height of this building. So that's why we had a negative there. And we cannot leave this answer like that. Sometimes what I would like to do, I would write downwards, but remember, at this point, we only care about a positive value there because the question set a value. Maybe let's even leave the downward part, but just understand it inside. Okay, we get a mark for this. We get a mark for the substitution. We get a mark for the answer, provided the unit of measurement is captured well. If not, then we are dead. But then, guys, be very careful. Is it safe to write this equation instead of writing perhaps Z is equal to like that? Is it not? Is it a problem? Now remember, this equation we derived by using this same formula above, so there's no harm in there. But confirm with your teachers, because you don't know what those people think, and therefore the teachers know better than I would. Okay, so don't be fooled by what I say. I am not the teacher. I'm certainly not the expert of the subject. I'm just one of those people who just like to talk about things they don't understand. Okay, let's look at y. What is y? So y is basically this height. Can you see what that height is? It's nothing but the maximum height. So we will need this portion right there. And then once we get that portion, we add these together, because that's what y is. Let's just show it differently. We can see that y is from maximum height all the way down. So this is y. So for us to deal with this y, we then need to just calculate this small portion up there, and then we add to this height we just got. So that's easy. So we know that the final velocity squared equals the initial velocity squared plus 2g delta y. So this implies that we've got 0. Remember, at maximum height, ball A is at exactly 0 meters per second. The beginning was 12 all squared plus 2 into minus 9,8. Now this is just y, right? Because that's what we want. We can say, therefore, okay, this y is a capital letter Y, so we need to be very careful on how we write it. This is going to be 0 squared minus 12 squared, all divided by 2 into minus 9,8. Okay, wait a minute, that's not y. Wait. It's not y. Let's just call it delta y for now. Okay, let's get this done. So we've got minus into 12 squared divided by 2 into minus 9,8. Okay, I get 7,347 meters to 3 decimal places just to protect our answer. We can say therefore y is going to be equal to 30,4 plus 7,347, which is going to be 30,4 plus 7,347. So I get 37,75 meters, because we're only focusing on the magnitude. Question said value, so it's just magnitude. All right, not a big deal. Nice equation, substitutions, intermediate answer, final answer. Please, the unit of measurement must always come out for this to be correct. Remember, at this point, the direction is not an issue, okay? Although this is position, but because we are only looking at the value, not interested in calculate. Because if somebody said just calculate z, we know z is a displacement, so we need to be careful about it depending on what we used. So we used ball A here in this calculation. So this is how we score those 4 marks. Nothing really out of the ordinary. Now let's look at 3.2. 3.2 says, on the same set of axes, sketch the velocity time graphs for ball A and ball B while they are in free fall. Okay, that means from launch till they hit the ground. Label the graphs A and B for ball A and ball B respectively. Clearly indicate the following: the velocity, initial velocity of each ball, the time at which each ball was thrown, okay, and the time at which the balls strike the ground. Okay, that's easy. We can handle that. So we will write here that this is the velocity time graphs of A and B with upwards taken as positive. Please guys, this needs to be stated clearly so that you don't get victimized for not stating these kinds of things. Of course, we need to write properly, but now I'm writing fast. With upwards positive. Okay. So be very elaborate. Take your time to make sure this thing comes out nice. So let's do our axes. Is it slanted? Yes? No? Looks better. Okay, that looks better too. So I don't need this part. So obviously this is 0. So this is going to be time in seconds. And then we've got here velocity in meters per second. So now here comes the trouble. So remember, these questions, they look easy, but guys, these are also higher order questions. You suffer if you're not very careful here. You need to think about what is going on constructively. First of all, there's that time lag of 2 seconds. So let's say that 2 seconds is here. Okay, great. And then what else do we know? That it all ends at 4 seconds. We can double this to here. Say that's 4 seconds. That's already okay. But remember, the directions of launch were different. So we can say this is the 12. Because this was upward, it's going to be positive. We can say this is the 5. So this is minus 5,4. Well, that was the downward. So this is very key. Now we know that essentially this graph started after a 2-second lag. So maybe let's do it. Let's do it. I need to make sure that this is really great. Hey, batla ho nketsang? Hey wena man, ska tina wena man. Yeah man. So that is cool because we know ball B starts here. But remember, it shows upward is down, so we know that the gradient here represents velocity. So we need to be sketchy about it. So the question is, how do these graphs look? Now, we need to know the time it took for ball B to reach maximum height, because this becomes a huge factor here. So let's do it. V equals U plus G T. Oh, and then you don't use these formulas, my lord. Vf is equal to Vi plus G delta T. We know at maximum height is 0. It came from 12 plus into minus 9,8 T. Therefore, T is going to be minus 12 divided by minus 9,8. We want to know, did it reach maximum height before 2 seconds or after 2 seconds? Because this will affect the shape of the graph. So this is minus 12 divided by minus 9,8. So this is 1,22 seconds. Can you see? This is before this 2 seconds. So it's 1,22. So maybe we say this is 1 second over here. It crosses over here. So we need to be very strategic and say, okay, let me choose a color that is nice. So this means we need to be very, oh Lord, no. This was launched straight like so. It's not a big deal. It looks like it's trying to defeat me. So let me shift my things. Let me shift my things. Doesn't really have to be to scale, isn't it? Yeah, we can put the 2 here and say this is the 2 right here, because I don't want the clash that is already happening. Let's leave this 4 seconds for now. Let's focus on the first part. So this graph is doing stuff like this. Here when Scotland Dina wena. Uskangetsa madugwe wena man. Aye man. That's much better. Masingaqhelwa kabi. Yare doch. E batla ho ntena jwale. Now, inketsa madugwenyana mana ska tlo nketsetsa mathaithai yona. Re tlo qabana inketsa so. Ayi wena masikamphapela wena man. Ye wena man. Kanti he wena. What's cooking with this thing now? I don't understand now. Okay. Young papel. You jump away yasemdantsane ngiqhela kabi. This one starts here. Okay, be very careful of how these graphs look. Maybe let's make this one a bit steeper as well, because wow, it's starting to annoy me. Let's just restart this whole thing before I freak out, because I feel like I should start freaking out. Is it freaking out or is it freaking out? Hey, sifundile what and says eqonda sasingakulinga nje sijongane ngala way foni nje ukuqaphuka. Okay, sizoyiqala apha. Very important. Okay, So we realized that this second ball was launched down when this one had already turned up there, because this is a side calculation you need to do on this side. I hope you guys have been watching my videos. I used to do this and it looked at first that it's crazy, but you see these things come in handy when it matters, because uzokhala. So we can say safely, okay, let's forget about the end point for now. Now let's focus on the next graph. So this graph is also going to slope the same way. It should be parallel to this one, right? Right, it should be parallel. And then now let's just make sure we strategize and show our 4. I mean, remember, this doesn't really have to be to scale, folks. Do I have enough space? No. So I'm gonna yay, ingathi sobanengxakana, but maske siyenze, guys. Let's do it. It's not good. I can go. Ngifunani kanye lento. Islantile still. Damn it, man. Okay, guys. Inenkani. Uminenkani ngiyeka khona la. So now this is what we need to do, guys. This is the stuff that we need to do. Okay, this is gonna be 4 seconds. Don't worry about the fact that it looks like it's too close, but it's not to scale, because I can see now if I try to do this right, it's gonna be problematic. But what matters is that this graph must be on top of this one, okay? Be very careful, because remember, the other thing that gives us a clue is the end point. Let's say this is the ground, right? Even this one is not so nice. Bastard. Anyway, guys, so that would be the end point, meaning that velocity. Now let's check what is the velocity with which it hits the ground. So we know that, well, the final velocity is the initial velocity plus minus the acceleration into 4. So you see this one is minus 27.5 for the blue. The blue one is minus 27.5. Okay, let's see what would be the velocity for that one. So it's minus 5.4 plus into minus 9.8 into 4. This one is not 4. Remember, this one is lagging by 2 seconds. So mistake. I need to substitute 2 seconds. This is minus 25. Can you see minus 25 is greater than this minus 27? So that means its end velocity, the velocity with which this one hits the ground, has to be higher than the velocity with which the other one hits the ground, because it came from a very high maximum height. So it will definitely hit at a greater velocity. So this is why it is very important to take care in these kinds of questions, guys. Be very, very careful. So this is it. But yeah, you can see my graph is not as nice. I don't like it when it's too long. So maske sithi we shortnisha kancane. So this is gonna be time in seconds. Okay, so how do we score the marks? Let's choose another color to mark. So we will get the mark for the two shapes because these are parallel. Remember, the acceleration is the same. So the gradients must be the same. So meaning these must be parallel lines. We get a mark for this. Shapes. Then we were told to show the initial velocity for each. So this is the one. Of course, we can mark that, but even this one, it started at -5. So 1 mark for both velocities. The time at which each ball was thrown. So of course this one was thrown at time 0, this one was thrown at the leg of 2, so we can mark it there, but provided both times are correct. If one of them is incorrect, you lose that mark. Time at which the two balls strike the ground, so this is the 4 seconds. Again, we are happy with that. So that's how we score these 4 marks for a total of a very challenging 16 marks. So it's easy to overlook this question. Be very, 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 very careful. These are questions that embarrass a student who does not know. So the graph should look like this, okay? So always do some side calculations to know exactly what should be where, because it's easy to draw a graph that is incorrect, something like this, and then you say for ball A it's like so, and then you say for ball B it's like so. If this is the orientation of your graphs, 0, because it won't be representative of this motion. Because look, if this is the case, remember for this time you're going to suggest that this one has a higher velocity, but do you see it's a smaller velocity than the other in terms of magnitude. So be very careful, don't be fooled. Some side calculations are very important because certain questions are technical in nature. Akudlalwa. Okay guys, I hope you enjoyed the video and you love it, and we will see you some other time. So leave a like, share it with your friends if you can, subscribe if you think you need more of these, because I'll drop in consistently. So you must be a subscriber and activate the notification bell so that when that happens you don't miss it, because it just might be your absolution towards gaining understanding and getting better at this. Anyway, just make sure you check for me with your teachers if this is allowed. But since I know where it came from this equation above, so this is acceptable. But just double check in case someone is wrong. And then of course verify any of these answers. I can perform some incorrect operations under the heat or the excitement, and I end up with some answers that are strange looking. So be very careful. Do not be dragged along that path of destruction. Keep vigilant, learn. Once you understand, practice. And I can assure you guys, there's nothing better than to try and draw your own sketch that you will understand, because sometimes this sketch can fool you, but study the sketch so that you can understand what is what. As we could see, this is just the delta y, which is the height of the building, and that's the maximum height for ball A. And those are the things that could be made sense by just an extra sketch, so that as you read the statement, you get to understand what is the task at hand. And you move along with it nicely. And this one will catch you if you are not careful. This one will catch you. So if you've been watching my videos, I always do side calculations whenever I feel the need, so that my graph, even though it's not to scale, but it actually transmits the same information that these graphs are actually giving, because it's easy to get it wrong. We forgot something, guys. Before we forget, this is for A, this is for B. If that is not there, guys, no one is going to know which graph is which. You lose marks for the shapes. Okay, so be careful. Otherwise, see you next time. Goodbye.